Today we are going to look at a concept known as the net present value, or NPV. It is a very common method and one of the first that we learn about when learning whether companies should accept or reject a project. First, let's go over some foundational time value of money knowledge that we should know before using this method. So remember, a dollar in the future is worth less to us than a dollar today. So if you have $1,000 today and you decide to stuff it under your mattress, and in 30 years you take out that $1,000 and you try and spend it, in 30 years you're going to be able to buy a lot less with that $1,000 than you are today. So let's go over a quick hypothetical example before we go into a real example where we will give a question and apply it. So let's just say a company wants to launch a product and it's going to cost them $5,000 to launch this product. So that's going to be a cash outflow of $5,000 today, and we're going to get 5 different cash inflows for this product. And then after these 5 years, this product will no longer go on. So we're going to get $1,000 each year for 5 years. It would be easy to look at this and say, well, we're indifferent between taking on this project or not and launching this product. We're going to get $5,000, so we're going to get 1,000 plus 1,000 plus 1,000 and so on for 5 years. So a total of $5,000 we're going to get as cash inflows, and we're going to have a cash outflow of $5,000. So it's easy to look at this and say, well, we're breaking even. But that's not actually the case, because remember, these $1,000 cash flows are happening in the future. So all these ones are happening in the future. So we have to discount them back to today, which I have a video linked in the description if you need a refresher on how to calculate the present value of a single cash flow. That is linked in the description below. I will go over it in a few seconds here, though, if you want a quick refresher. But this 5,000 cash outflow is happening today. This is an expense that is happening today, and we are getting this $5,000 in the future. So if we remember time value of money, we shouldn't take on this project, because we are actually worse off taking on this project because we are going to have a negative NPV, and we'll see how to interpret that when we go over this next example. So before we get into our example, let's continue this example and let's remember how we calculate the present value of a single cash flow. So the present value is equal to C over 1 plus R to the exponent T. So let's just discount this 5th cash flow for practice. So let's see. So C is our cash flow. That's our $1,000 that we got right here. And we're dividing that by 1 plus R to the exponent T. So R is 5%. Think of this as an opportunity cost that the company could have gotten investing in a different asset or different projects if they didn't do this one. So let's say they could have invested stocks, for example, and they could have gotten this 5% return, but instead they chose this project. So think of this as almost as like an opportunity cost to the company. So 1 plus 0.05 or 1 plus 5% is 1.05. So that's 1 plus R. And we're discounting this cash flow. Remember, we're doing it for this one right here. And so we're going to put it to the exponent 5. And that's how you discount basically a single cash flow. So we now have discounted that back to today. So whatever this is equal to, that is the present value of this $1,000. So before we go on to another example, let's just calculate the NPV, or net present value, of the projects we've been talking about. Remember that we said this $5,000 cash outflow today over here would be worth more than the $5,000 that we're receiving in the future. I know we're not receiving the $5,000 all at once, but we're receiving a total of $5,000 across multiple different years. Remember, $1,000 in year 1, 1,000 in year 2, and so on for a total of 5 years. So our cash outflow at the beginning is $5,000, and we're receiving a total future value of $5,000. But the present value of this $5,000, if we discount all these back, which we did right here using this present value formula, is only equal to, when you solve this out, 4329.48. So as we can see, the present value of these cash inflows, which are in green here, the $1,000 cash inflows, the present value of them is less than the $5,000 cash outflow, which was the cost of making this product for this company. So this project has a negative NPV. So how we calculated that was, we took the negative 5,000, which is our cash outflow, and we added it to the present value of all our cash inflows. And when you do that, you get, and you add them all together. So added up, we discounted this one back, we discounted this cash flow back, and did it for all 5 $1,000 cash inflows, and we got a present value of 4329.48. So the negative NPV here represents that this 5,000 cash outflow is worth more than the present value of the cash inflows we will receive from this project. So when the NPV is negative, so when the NPV is less than 0, we would reject the project, which we are going to do in this case. But if it was positive, we would accept the project, because think about it, that would mean the future value, or the present value of our cash inflows, is greater than the cost of the investment. So if the NPV is going to be greater than 0, we would want to accept, because that means our cash inflow, or the present value of our cash inflows, when you add them all up, is greater than the initial costs of the project today, our initial investment. So now let's go over this example. So a company is considering investing in a small project that costs $3,800 today. The project is expected to generate the following cash inflows over the next 3 years. The required rate of return is 6%. Should the company accept or reject this project? So first, let's realize that the cash outflow is the $3,800. So it's going to be negative $3,800. That's going to be our initial cash outflow. That's our initial investment. Then it's going to generate these cash flows here. So $1,000 in year 1, $1,500 in year 2, and $2,000 in year 3. And the last piece of information that we need is the required rate of return, or our discount rate, which is going to be our value, and that is given to us as 6%. So remember I said, think about the 6% as the opportunity costs, or the rate of return the company could have gotten if it invested in a different project, or stocks or bonds or something else. It could have gotten that 6% return. So that's why we use it as this discount rate. And one last tip before I let you try this on your own is, when I'm doing these questions, I like to draw timelines. So how I like to do this is I like to label, we have 3 years of cash flow, so I'll do 3 spots, and I'll do 0, which is today. So today what happens, we have a negative cash outflow of $3,800. So I like to plot that here. And then I like to draw out on the timeline our cash inflows. So we're getting $1,000 in 1 year, and then we'll know we'll be able to visualize and discount it back. And then in 2 years we're getting $1,500, so I'll write that here. And in 3 years we're getting $2,000, so I'll write that here. And it just helps me visualize what's going on. And then it's a lot easier to kind of do the question, because you can just discount this back for the 1 year, discount this back, and we'll know it's 2 years, and discount this back for 3 years. So go ahead and try that, and remember, accept the project if the NPV is greater than 0, and reject if the NPV is less than 0. So this is the answer you should have come up with. How we calculated this is, we took the negative $3,800, which was our initial cash outflow, or cost of the firm investing in this project today, and then we discounted these cash inflows back to today to get the present value of them, which is what we did right here. When you solve for that, you get a value of $3957.63. So when you find the NPV, you take the negative $3,800 and you add it to this $3957.63, which again is just what this works out to, and then you get a positive NPV of $157.63. And remember what we said about positive NPV, when it is greater than 0, that means we accept the project. So we would accept the project in this case because the project results in a positive NPV, or in other words, the present value of the cash inflows is greater than the initial cash outflow or initial investment. One last thing I'll point out is that the cash flows in this case, so the cash inflows, were different, so we had to discount them back individually. If these were all the same, we could use a shortcut and use a present value of an annuity formula, which would save us from discounting them back all individually. In this case, it's not too bad, there's only 3 years, but if there were 30 years, for example, instead, and all the cash inflows were the same, we'd want to use the present value of the annuity formula, as it would save us a lot of time. So I will link a video in the description below on how to do that, but remember, to use an annuity, all the cash flows have to be the same. So all the cash flows in this example would have had to been, let's say, $1,000, or they would all have to be equal to each other in order to use that shortcut. If they are different, like they are in this case, you do have to discount them back like we did in this example.